A body travels 60 meters in the third second and 90 meters in the sixth second. What is the acceleration? Options are 3.75 meters per second squared, 4 meters per second squared, 5 meters per second squared, 10 meters per second squared. Correct answer is 10 meters per second squared.
Let's say you know the distance traveled by the body at 12 seconds, which is s3 equal to 60, and the distance traveled by the body at 6 second, which is s6 equal to 90. To find the acceleration, in this situation, you need to apply the general formula of displacement in the nth second, which is Sn equals to u plus half into a into 2n minus 1, where Sn is the displacement during the nth second, u is the initial velocity of the object, a is the constant acceleration, n is the specific second for which you are finding the displacement. Substituting the given values for the third second, the formula becomes S3 equal to u plus half a into 2 into 3 minus 1, which is equal to u plus half a into 5, which simplifies to S3 equal to u plus 5a by 2. Substituting the known displacement, 60 equal to u plus 5a by 2. Similarly, for the sixth second, when we substitute the values, it becomes 90 equal to u plus 11a by 2. Now, we need to subtract the equation 1 from equation 2, which is 90 minus 60, which is equal to u plus 11a by 2 minus u plus 5a by 2. While simplifying, it becomes 30 equal to 6a by 2, which is 30 equal to 3a. Solving the acceleration is equal to 30 by 3, which is 10 meter per second square.
A body travels 50 meters in the nth second and 60 meters in the n plus 3th second. What is the acceleration? Options are 5 meters per second squared, 6 meters per second squared, 7 meters per second squared, 33.3 meters per second squared. Correct answer is 33.3 meters per second squared. We know the distance travelled by the body at nth second and n plus 3 second. Substitute this formulae in Sn equals to u plus half a into 2n minus 1 and subtract the final values. Here, the answer is 3.33 meter per second square. A body moves with uniform acceleration and travels 72 meters in the 4th second and 96 meters in the 7th second. What is the acceleration? Options are 4 meters per second squared, 8 meters per second squared, 6 meters per second squared, 5 meters per second squared. Correct option is 8 meters per second squared. We know the distance travelled by the body at 4th second and 7th second. Substitute this formulae in Sn equals to u plus half a into 2n minus 1 and subtract the final values. Here, the answer is 8 meter per second square. A body travels 100 meters in the 5th second and 120 meters in the 8th second. What is the acceleration? Options are 6.67 meters per second squared, 6 meters per second squared, 8 meters per second squared, 10 meters per second squared. Correct option is 6.67 meters per second squared. We know the distance travelled by the body at 5th second and 8th second. Substitute this formulae in Sn equals to u plus half a into 2n minus 1 and subtract the final values. Here the answer is 6.67 meter per second square. A body travels 40 meters in the 2nd second and 50 meters in the 4th second. What is the acceleration? Options are 2.5 meters per second squared, 3 meters per second squared, 5 meters per second squared, 4 meters per second squared. Correct option is 5 meters per second squared. We know the distance travelled by the body at 4th second and 5th second. Substitute this formulae in Sn equals to u plus half a into 2n minus 1 and subtract the final values. Here the answer is 5 meter per second square. A body of mass m is dropped from a height h and rebounds to a height h divided by 3. What is the percentage loss of total energy and the velocity of the ball just before it strikes the ground? Options are 66.67% square root gravity height, 66.67% square root 3 gravity height, 50% square root 2 gravity height, 33.33% square root gravity height. Correct answer is 66.67% square root gravity height. The problem involves two parts. 1. Percentage loss of total energy. 2. Velocity of the ball just before it strikes the ground. Here apply the formulae: energy equals to mass times gravity times height. After rebounding to height h by 3, the total energy is mgh by 3. Energy loss is the delta of the initial energy minus final energy, which is 2 mgeh by 3.0. Percentage of loss is 66.67%, and velocity just before striking the ground is using equation of freefall, square root 2 JEE. A ball is dropped from a height h After rebounding, it reaches a height 0.8 h. What is the percentage energy loss during the fall and rebound? Options are 20% square root gravity height, 20% square root 2 gravity height, 10% square root gravity height, and 10% square root 2 gravity height. Correct answer is 20% square root 2 gravity height. The problem involves two parts. 1. Percentage loss of total energy. 2. Velocity of the ball just before it strikes the ground. Here apply the formula Z energy equals to mass gravity, see height, after rebounding 0.8 meters per hour. 3. Energy loss is the delta of the initial energy minus final energy mgh minus 0.8. mgh equals to 0.2 angstrom. Percentage of loss is 20%. And velocity just before striking the ground is using equation of free fall square root 2 GA, or a body is thrown vertically upward with an initial velocity u. At the highest point, its velocity is 0. What is the time taken to reach the highest point? Options are u by g, 2u by g, u raised to 2 by g, and u by 2g. Correct answer is u by g. To calculate the time taken for a body thrown vertically upward to reach its highest point, we use the equation of motion under constant acceleration due to gravity. Given initial velocity as u final velocity. At the highest point, v equals to 0. Acceleration due to gravity acting downward is minus g. Substitute the values in the equation of motion, ev equals to u plus a into t. The time taken to reach the highest point is u by g. A particle is dropped from a height h. The velocity of the particle just before it hits the ground is v equals 2 meters per second. What is the height h from which it was dropped? Take g equals 10 meters per second squared. Options are 1 meter, 2 meters, 4 meters, and 5 meters. Correct option is 1 meter. To find the height h from which the particle was dropped, we can use the equation of motion under gravity. Given final velocity v equals to 2 meters per second, initial velocity u equals to 0. Since the particle is dropped, acceleration due to gravity g equals to 10 meter per second square. The equation that relates velocity, acceleration, and distance is v square equals to u square plus 2 into g into h. Substituting the given values, h is solved. The height h from which the particle was dropped is 0.2 meters. A block of mass m is moving with a velocity v on a frictionless surface. What is the momentum of the block? Options are mv by 2 mv square. Correct answer is mv. The momentum, p, of an object is defined as the product of its mass, m, and velocity, vp equals mv. The momentum of the block is mv.
Thank you for watching our channel Riddles to Rank JEE. All the best.